What's the difference between add and copy instructions in a Docker file? Sir, both copy and add commands serve the same purpose, which is to copy the files. But as per Docker's official documentation notes, it is always recommended to use the copy instruction instead of add, since the copy instruction is more transparent and straightforward. The copy instruction is used to copy files or directories from your host machine into the Docker image. On the other hand, add instruction has additional capabilities such as extracting tarballs and copying remote URLs. The use of add instruction is discouraged for all the cases except when the user wants to extract a local compressed file. So hence it is recommended to use the copy instruction over the add instruction. Okay. What are the options of persistent storage in Docker? Sir, we have two options of persistent storage in Docker: volumes, bind mounts. Okay, now please differentiate the volumes and bind mounts. When we use the volume option, it creates a new volume in varlib docker volumes directory, and our data would be saved on the host machine if we remove the container. We can attach one volume to multiple containers at the same time, and also we can attach multiple volumes to a single Docker container. Okay. Whereas in bind mounts, a file or directory from the host machine is mounted into a container. So for instance, if I have a logs directory and I want to mount it, I can use the bind mount option to mount that logs directory to multiple containers at one time. Okay. But as per the people's opinion and Docker's recommendation, using volumes is more reliable, it's speedy and efficient way for persistent storage in containers. We can easily create, remove Docker volumes using the Docker volume command. Gotcha. Would you mind sharing a couple of Dockerfile instructions and also tell me what they are used for? Sir, since we know that Dockerfile is a text file which uses instructions to assemble a Docker image, that Docker image is actually a custom image that we can build according to our needs. So there are a couple of instructions that I would like to share. The first instruction is the from instruction. A Docker file starts with from instruction, and it is the very first instruction which creates the base image layer. And after that, each instruction will add further layers. Okay. The other instruction is copy, which copies a file from the host to the image. The third instruction is run, and it is used to run the commands inside the image. The fourth instruction is environment, env, and it sets the environment variables that can be used inside the Docker file. The fifth instruction is cmd, and it specifies what command to run when the container starts. Just like cmd, we can also use the entry point instruction to do the same job. Perfect. Can we mount a single directory to multiple containers? Yes, sir, we can mount a single directory to multiple containers at one time. And in fact, this is one of the best approaches when we have to share the data among multiple containers. For instance, we have around 20 containers running on our host machine, and they need access to a single directory which contains an important data. Then we can mount this single directory to all the containers so that they can share the data among themselves. And while we are using the bind mount, we will use -v flag while running all those containers so that they can use this directory. It means that we can mount the same directory with the help of -v flag, mentioning the directory's full path so that all the containers can see this path. And whatever happens to this directory, it would be automatically replicated on all the containers because this directory is mounted on all the containers. How would you mount a volume to a container? Would you please explain the command? Sir, in order to mount a volume to a container, we should create a volume first. So we can use the docker volume create command to create a volume. so that when we have created this volume, we can mount this volume to any container we want. So in order to create a new volume, I would use docker volume create my volume. My volume is the name of the volume that we are going to mount to a container. Now we will spin up a new container and we are going to mount this volume to that container. So the docker run command would be used to spin up a new container, and we will use the mount option, which is the mount flag, which helps us to mount our volumes to containers. Now there is an important thing to keep in mind. We have to specify the source and the target. Now our source would be our volume, my volume, and the target would be the target directory inside the container. For instance, I want to mount my volume inside user share nginx HTML. So the command would be docker run -d, which will run the container in the foreground, hyphen name, the name of the container, for instance, web server 1, hyphen mount. Now we will have to specify our source. Source is equal to my volume. And now we will have to specify the target. Target is equal to user share nginx HTML. And at the end, the name of the base image. So that's how we will mount our volume, which is my volume, inside the container's user share nginx HTML directory. We can see this volume created on our host machine in varlib docker volumes. Okay. What is the difference between multiple run and single chained run in Dockerfile? So first of all, we must know what is the purpose of run instruction in a Dockerfile. The run instruction is used to execute any command in the Docker image. So we can run any command in a Dockerfile like run apt install nginx, or run npm install, or run npm build, etc. Now each run instruction will create a new separate layer. And if we are using the run instructions separately, then these instructions will add a new image layer. And so our image size would be increased. Therefore, it is recommended not to use multiple run commands. Instead, we must use single chained run command. So we can combine multiple run commands with the AND operator, and we can have multiple run commands in a single run instruction, and it will create only one image layer. And that's the benefit of using single chain run instruction in Dockerfile, so that the image we get must have a reduced image size, and it will not take much time to build the Docker image. So it is always recommended to use single chained instead of multiple run commands in the Dockerfile. Okay. Can we have multiple from instructions in a single Dockerfile? Yes, sir, it is possible to have multiple from instructions in a single Dockerfile. And this phenomenon is known as multi-stage builds in Docker. So there can be multiple from instructions in a single Docker file. And the purpose of using multiple from instructions is to get the final image with a reduced image size. And this process not only reduces the image sizes, it also speeds up the image build process. And in multi-stage builds, the first image that is produced from the first from instruction becomes the base image of the second instruction. Okay. After we install Docker, we normally face a common error of got permission denied while trying to connect with the Docker daemon socket. Have you faced this error? Yes, sir, I have encountered that error for quite a lot of times. So what's the fix of this error? The reason of this error is that our user is not authorized to run Docker commands, and our user does not have the necessary permissions. So when we install Docker, a default Docker user and group is also created. So in order to run Docker commands without any issues, we must add our user into the Docker group. Okay, so we can run the user mod command. User mod is used to modify any user. So for instance, if my user is DevOps Molvi, I would run the command as sudo usermod -ag docker, because we are going to add our user into the Docker group and then our username. So this command would add our user into the Docker group. And after that, we must log out from our terminal session and log in back so that our user is able to run all the Docker commands. Perfect. What are the best practices to reduce image size in Docker? Sir, in order to get the reduced image size in Docker, we must follow the following practices. We must use a smaller base image like from BusyBox or Alpine Linux. Alpine Linux is as small as 5 MB. So our base image should have a minimal size. We should not install debug tools like curl, vim or nano. We must minimize the image layers as much as possible. If the image layers are higher in number, the image size would be greater. We must use multi-stage builds in Docker. And we must ignore dependencies and files while installing any software package. Instead of using multiple run commands, we must use chained run commands. So these practices can reduce our image size in Docker. Okay. Can we remove a mounted volume from a container? No, sir, we cannot remove a volume which is already mounted to a container. And if that container is running, it will not allow us to remove a volume because that volume is actually attached to that container. So first of all, we have to make sure that this volume is of no use and we can safely remove it. And it does not have any important data because removing a volume is a critical thing. Once we make sure that it is an unused volume, then we can unmount this volume or we can detach it from the container. Once that volume is unmounted and detached, we can safely remove this volume from the container. The Docker volume rm command, Docker volume remove my volume, or the name of the volume, is used to remove the Docker volume. Okay. Can we delete a Docker image if there is a running container of that image? No, sir, we need to delete the container first. What's the command to remove a Docker image? We can use Docker RMI command to remove a Docker image. RMI stands for remove image. Docker RMI image ID or image name, and it will remove the Docker image. How can we forcefully remove a Docker image? We can use the -F forcefully flag to remove a Docker image forcefully. What is the best practice to remove Docker images? Sir, the best practice to remove only those Docker images that are no longer used by the Docker containers. And if we maintain multiple versions of those Docker images, then we can safely remove those Docker images off of our VM. How can we use a single Docker image to run multiple Docker containers? Sir, we can create as many containers as we want using a single Docker image. So it's obvious that a single Docker image can be used to run multiple containers with the help of Docker run command. So it means that it is possible to run multiple Docker containers with a single Docker image, since every Docker container has its own data and its state. We can have multiple containers with different name using the name flag. So if I want to share a scenario, for instance, we are going to run multiple containers using the single Nginx Docker image, then we can use this Nginx Docker image to run multiple Docker containers with different names like Web Server 1, Web Server 2, Web Server 3, and so on. And we are using only one Docker image, which is Nginx. So in order to avoid conflicts, we must use different container names using the name flag. So that is also the beauty of Docker, because it allows us to run hundreds of containers using a single Docker image. Okay. And this process can speed up our development and deployment processes when we are using Docker for CI/CD pipelines. So finally, we must keep in mind that we must specify a unique name for the every container we run with the help of that Docker image. Perfect. Can you explain the difference between containerization and virtualization? Sir, there is a huge difference between virtualization and containerization. Virtualization allows you to create virtual machines from the underlying hardware resources. And that's what the key difference, by the way. And virtualization uses abstraction layer, which is known as a hypervisor. Whereas containerization is also a form of virtualization in which an application is bundled along with its code, libraries, dependencies, and everything else needed for it to run inside a component which is known as a container. Alright. What are the Docker image layers? So basically an image layer is a change in the Docker image. Every command we specify in a Docker build like run, copy, add, cmd, entry point, it causes the previous image to change, thus creating a new layer. So we can say that each layer in the image contains a set of file system changes, modifications, additions, or deletions, and we can understand it with an example of Python application image. For instance, we have a Docker image for Python application. It would contain 5 layers. Okay. The first image layer adds the basic commands like apt or package manage. The second image layer installs a Python runtime and pip for dependency management. The third layer copies application's specific requirements file. The fourth layer installs that application along with its specific dependencies. And the fifth layer copies the actual source code of the application. And that's how image layers are created to have the final Docker image. Perfect. What is a Docker engine? Sir, the Docker engine is a client-server application which provides the core functionality for building, running, and managing Docker containers. The Docker engine consists of a Docker daemon which acts as a server and a Docker CLI which acts as a client, and both Docker daemon and Docker CLI communicate with each other. Okay. The Docker engine manages the container lifecycle, networking, container storage, and other essential aspects of the Docker platform. In other words, we can say that Docker engine is a containerization technology or an open source containerization platform which helps us to build and containerize our applications. The simplest definition of Docker engine is that software which hosts the containers. The Docker engine was first released back in 2013 for the first time by Docker Incorporation. So without a Docker engine, we cannot build or run any container. All right. Would you mind sharing some details about a Docker image? What is a Docker image? Sure, sir, why not? A Docker image is a lightweight, standalone, and executable software package which includes everything needed to run a piece of software, including the code, runtime, libraries and dependencies, and system tools. In other words, we can say that Docker images are read-only templates which contain instructions for creating a container. A Docker image is a snapshot or blueprint of the libraries and dependencies that are required inside a container for an application to run. Last but not the least, a Docker image is an artifact or a package which includes all the files, binaries, libraries, and configuration to run a container. We can build the custom images of our own choice by writing the Dockerfile. A Dockerfile contains the instruction to build the image of our own choice. And we can build Docker images with the help of Docker build command. What is a Dockerfile? Sir, a Dockerfile is a text file which contains a set of instructions. And those instructions are used by the Docker build command for building a custom Docker image. So we can say that Dockerfile is a file which combines all the instructions to build a custom Docker image. For instance, if I run docker pull WordPress or docker pull MySQL, these commands will pull Docker images from hub.docker.com. But what if I want to build and have the image of my own choice? Then Dockerfile would be used, which contains all the instructions that I can write myself to have a custom Docker image. Okay. And it is super easy to write a Docker file from scratch because there are a couple of instructions that you must know how we can write and execute those instructions. Perfect. What is containerization? So, containerization is a type of virtualization in which all the components of an application are bundled together, and that bundle is known as a container image or a Docker image. Okay. And we can run that Docker image into an isolated container with an isolated user space on the same shared operating system, and that is containerization. We can have hundreds of containers on a single virtual machine. What is Docker? Docker is an open platform for developing, running, and shipping applications. Why we use Docker? Docker enables you to separate your applications from your infrastructure so that you can deliver software quickly. With Docker, we can manage our infrastructure in the same way we manage our applications. And also, Docker plays a crucial role in CI/CD pipelines. We can have multiple applications running on the same virtual machine using Docker containers. Perfect. What is the difference between CMD and entry point instructions in Docker? Sir, CMD and entry point are two Dockerfile instructions that serve the same purpose to run a command when a container starts. So we must use these instructions in our Docker files so that users can easily interact with the containers. Since CMD and entry point serve the same purpose, so users often get confused while understanding the difference between CMD and entry point. So entry point is the process that is executed inside the container, whereas CMD is the default set of arguments that are supplied to the entry point process. CMD can be easily overridden by modifying our arguments, whereas we cannot override entry point instructions. So it means that the users cannot override entry point instructions, whereas CMD can be easily changed or overridden by the end users with the help of Docker run command. So I would always say that entry point is superior. What's the difference between a container layer and an image layer? So when a container is created from an image, Docker creates an additional container layer on top of the image layers. Container layer is a read and write layer which stores ephemeral data generated by the container during the runtime. By ephemeral, I mean to say that this is a temporary data, and that data lasts only when the container is running. So it means that the data that is stored in the container layer will be lost if the container is deleted. That is actually ephemeral storage means. Okay. So image layers are used to build the Docker images, and the container layer contains the data which is needed for that container at runtime. Hey, hi. What are the three primary components of Docker? Sir, actually there are three primary or main components of Docker. Number one, Docker client. Number two, Docker host. And number three, Docker registry. Docker client is used to communicate with the Docker host, and it uses the Docker run and build procedures. The Docker host is a service that allows us to host containers. It is the key service which helps us to build and run Docker containers. And after all, when we build and ship our Docker containers, those Docker containers are converted or stored in the form of Docker images into a Docker registry. For instance, Docker Hub. Okay. So these are actually the major components of Docker, and along with that we have also Docker command line or Docker CLI, Docker volumes, Docker networking, Docker files, Docker storage. These are all used in Docker. And the core purpose of these Docker components is to build and run our applications into Docker containers. Gotcha. If we remove a container, what happens to its data? Sir, if we remove the container, the data on that container would be lost. Since we know that the container stores its data, which is known as ephemeral data, on the container layer. And that data is ephemeral because it is temporary data. And that data would be lost if the container is removed. In other words, the data do not persist when that container no longer exists. So if we are not using volumes or bind mounts, we should take extremely care before removing or deleting any container, because the resources, the metadata of that container would be lost if the container is removed. Okay. And this is one of the most sensitive things of Docker. Even if we restart the container, the data would be lost. So there is always a recommended practice to use volumes or bind modes for persistent storage. Gotcha. Can you tell me where Docker stores all of its data on the host machine? Sir, on Linux, Docker stores all of its data like images, containers, volumes, networks. It is stored in var lib docker directory, also known as the root directory of Docker. So the var lib docker directory contains more directories to store volumes, networks, images, and containers separately. What I mean to say that there is a separate directory for volumes, there would be a separate directory for networks, and like for images and containers. Okay. So the Docker volumes are stored in varlib Docker volumes. Similarly, the networks are stored in varlib Docker networks. By the way, Docker uses overlay file storage system to store all of its data. Perfect. What's the difference between a Docker image and a Docker container? Sir, I would like to share a yummy example to differentiate between a Docker image and a Docker container. Docker image is the recipe and the Docker container is the cake. We can make as many cakes as we want with the given recipe. And now if I differentiate the Docker image and the Docker container, the image is the snapshot of the container and the running instance of that image is a container. Docker image is the template and the Docker container is the running software of that template. We cannot run any Docker container without a Docker image. And the first step is to build Docker images so that when we have Docker images ready, we can run them into Docker containers. Okay. For instance, if we have one single Docker image, we can run thousands of Docker containers using that single image. What are the Docker object labels? Sir, Docker object labels are used to apply metadata to the Docker objects like containers, images, local daemons, networks, and nodes. We can use Docker object labels to organize our images. We can also record licensing information, and we can watch the relationships between the containers, volumes, and networks, or in any way that makes sense for our business. A Docker object is a key value pair and it is stored as a string. Okay. We can also use label instructions in Docker files as well. For instance, I have an image and its version is 1.0 for instance. Then I can use the label instruction in my Docker file to add the metadata for that image as label is equal to 1.0. So my Docker image will have the version label as 1.0. Similarly, we can use these Docker object labels to add metadata for our volumes, networks, and containers. What is the command to pull a Docker image? Sir, the Docker pull command is used to pull any image from our Docker image registry. For instance, Docker pull and the image name, like Docker pull Ubuntu and its tag like latest. So we can say that in Docker, downloading any image from a remote repository is known as pulling. How Docker pull command works? Docker pull command plays a crucial role in obtaining container images from a specified remote registry. Docker pull command allows developers and DevOps engineers to fetch pre-built images that can be used as the base for building and running containerized applications. By pulling images from a registry, the DevOps engineers can save time and effort by leveraging existing solutions and dependencies instead of starting from scratch. So when we run Docker pull command, the command identifies the image and it contacts with the Docker registry and authenticates. And after the authentication is done, the image is downloaded in the form of layers and those layers are assembled together to form a Docker image. Okay, so that's how the Docker pull command is used to pull Docker images from our Docker registry. The Docker registry can be Docker Hub, Elastic Container Registry, or Azure Repository. If I want to remove everything like Docker volumes, containers, images, networks, everything, do you know a single command that does this job? Sir, we can use Docker system prune command, but with caution, because it will remove all the stopped containers, it will remove all the unused networks, and it will also remove all the unused images, except volumes. Since our volumes store our data and volumes are used for persistent data storage, so the volumes are not removed by the Docker system prune command. However, we can use the -a and volume switch to remove all the unused volume with Docker system prune command. But since it is a dangerous command and it will remove all the unused networks, containers, images, and build cache that you may need in the future, we must use this command with caution. Okay. What are Docker volume drivers? Sir, Docker volume drivers are used to store volumes on servers and even on the cloud environments. These drivers are also used to encrypt the contents of the volumes. Which one is the default Docker volume driver? So the default driver is local. Docker uses local volume driver if there is no driver specified. So we can say that local is the default volume driver. Okay. Would you mind sharing all the Docker volume subcommands? Sir, first of all, we need to understand that we can manage volumes on Docker with the help of Docker volume command. Okay. There are around 6 subcommands of Docker volume command. Number 1, Docker volume create. It will create a new volume. Number 2, Docker volume inspect. It will share all the details of any volume. Number 3, Docker volume ls. It will list down all the volumes we have on the host machine. Number 4, Docker volume prune. It will remove all the unused local volumes. Number 5, Docker volume rm. Rm stands for remove, and this command is used to remove one or more volumes. Number 6 is Docker volume update, which is used to update any given volume. Perfect. So if you have a volume and a bind mount, what would you prefer? Sir, if I have been given the choice to use either volumes or bind mounts, I would prefer using volumes. Why would you prefer volume over bind mount? The reason is that volumes are completely managed by Docker, whereas bind mounts totally depend on the directory structure and the operating system of the host machines. Volumes are totally independent, and we can also move volumes from one host machine to another. We can attach multiple volumes to multiple containers at the same time. Okay. So volumes provide more flexibility over bind mounts, and that's why I would prefer using volumes over bind mounts. That answers my question. Thank you. How can we remove all the containers, whether they are running, stopped, or paused, using one command? So we can use the Docker rm command to remove the container. We have to specify the container ID or container name. But in order to remove all the containers using one command, we need to understand how this command would work. Actually, it is the merger of two commands. There is one command that acts as a variable and it gets all the container IDs. And those container IDs are passed to the first command, which will remove all those containers. Okay. So Docker ps, which shows us all the containers, or Docker ps -a-q, we will get all the container IDs, whether those containers are running or stopped or even paused. And once we have those container IDs, we will pass those container IDs to our Docker rm-f command, and it will forcefully remove all the containers in one go. However, this command is highly dangerous because it will remove all the containers, so we should use this command with caution. Perfect. If I want to remove all the Docker images at once, what would be the command? Okay, would you like to explain this command, how it works? So we can use the Docker RMI, which stands for remove image command, by mentioning the image name or image ID, and it will remove the Docker image. But in order to remove all the Docker images from our VM or from our server, we need the image IDs of all those Docker images, and we can get those image IDs with the help of Docker images command. Okay, would you like to explain this command, how it works? This command will work like Docker images -a-q, and after running this command we can get all the Docker image IDs so that we can pass these image IDs to the Docker RMI command to remove all the images in one go. Okay. So it means that there are two commands that are combined together to remove the Docker images. So the Docker images -aq will get all the Docker image IDs, and these IDs are passed to the Docker RMI command. We can also use the -f switch to forcefully remove all the images. So the full command would be docker rmi -f $docker images -a -q, and all the Docker images would be removed.